Hello. At Earthmetry, we provide data sets on various areas like energy, air quality, climate, and so on. These data sets are delivered through our Signals platform, which is like a no-code data visualization platform which we can use to explore data sets or create charts and dashboards. Today, we're just going to see how to navigate to the data sets that you would like to use and what kind of aggregations you might want to perform or how you may want to explore the data. Now, just quickly going to the platform, it looks like this when you first log in. It's like your home screen, and this shows you recent dashboards that you've created or charts that you've created and so on. And this whole tool is actually based on the open source Apache Superset project. So it is a modern data exploration and visualization platform. And if you go to their website, you will see a lot of documentation as well. So if you go to the documentation and you are mostly going to be using it, so you could go to this section where it says use Superset, and you can use these sections to sort of decide what to do. So if you go to exploring data, for example, it shows you various screenshots and help documentation, and so on. So you can actually scroll through this various types of charts and so on to understand how to do what you want to do, right? So let's have this as one resource, and you could also just go to YouTube and search for Apache Superset, and you will sort of get to see what's going on. And maybe there are some specific videos on specific features and so on that you can get to using YouTube. So today we are going to see how we set up the platform for you. So you can actually go to the top right here, there's a help button, and if you click that, it opens up a detailed table reference. And as you can see, there are tabs that denote different types of sectors or different types of sectors for which data is available. So you have air pollution as the first one, electricity, oil and gas, and so on, right? So today we're just going to look at electricity for a bit, and within electricity there are again multiple types of data sets. So you have where is the electricity coming from, what are the sources, generation and the capacities that are available, how is the electricity scheduled for different buyers, which could be mostly the states or the discoms in India. And then you go to electricity consumption, which covers how much electricity is used at various levels, usually at state, but some data sets are at time block level, some are daily, some are monthly, and so on. So these are the most common tables that you might be using if you're interested in electricity sector, right? And right here under consumption, for example, let's take the example of state level real-time data. Now, as you can see, we used to cover it from a certain source that was not very reliable, and we later moved to a new source from Merit. And this is procured. So you have some details mentioned here on how the data set is procured, or what columns it may have, or what processing it is being taken through. And you can understand that before you step into the tables. Now, there are three tables that are set up for this. One is labeled real-time demand, one is time block, and one is hourly, right? So these are the various things. Just as an example, if you click on the time block, it takes you to explore that table, right? And these are the columns on the left that are available in the table. And these are all the settings and controls that the user has to create or craft a query, and then it populates a particular chart. Now, before we dive into the data, I'll show you another way you can reach here. So you can actually just go to data and data sets, and over here all the tables are available as well. So you can just search for energy, right? And you will see what are the energy tables, and or you could have searched for state or time block as well. So in this case, you can actually get to the table. The table names are pretty descriptive. So you can arrive at it. If you've already used this table and know the name, you can just search for it in datasets. So before again doing that, we'll also show you where the charts sit. So here's where, so you click on charts and it shows you all the charts that everyone has saved, and also dashboards, right? That different people might have saved. So just going back to this, what is a chart? A chart is simply a particular view of data. It could be a time series chart, it could be a simple table that is created using one data set, right? And so you will basically go to data sets, and let's now go back to that data. This time I'm going to search for state, and I'm going to find my table over here. So I'm going to go here and start looking at it, right? Now, before we get into the details, I'd like to show you all the types of charts that are possible. So you can click on view all charts, and you will see that the default is actually just a table, plain old table. But if you click on all charts, you will see all the different charts. Most of the time, you're going to be working with some sort of a time series chart. So you can just go to evolution, and there is line chart, which is a simple line chart, and there are some other charts here that sort of have x-axis as time, and let you do various kinds of plots, right? So you can select the chart here that you want to plot, and then you can start your work, right? Now, a couple of things here. There is always a time column in Superset that you work with. Typically, for very large data sets, you should be filtering this as well, or aggregating in some way. Otherwise, if you're pulling way too many rows, it may not be able to handle it. So in this case, the main time column is the time block start time. So in India, for electricity, there is a 15-minute time block. So at midnight, the clock starts, and at 0015 hours, the next time block starts, and then 0030 hours, the next one, and so on, right? So that's what the time block start time indicates. And the next thing is time grain. So this is actually an aggregation thing where you decide how you want to aggregate the data. So for example, if you want to just aggregate it to day level, you will select day. Or if you want to leave it where it is, you can select either original value, or in this case, it's a minute sort of thing. So you can select minute. If you leave it at original value, there is no aggregation that is done. The data is presented as is when it comes to the time block. The next one is a filter. So if you go here, there are various types of filters possible. So you can say, last week, last day, and so on. You can also do a, previous calendar week, calendar month, calendar year. These are the preset sort of filters. There are also custom filters where you can, decide whether it's a relative date and time, like for example here it says 7 days before, or whether it is specific. For example, here it says midnight of 14th July, right? So in this case, we're just going to look at a specific date and time, and I've just curated a time period, so I'm just going to select it. So I'm just going to select 1st of June, and over here as well, I'm going to select about 1 week of data. So let's go to 7th of June and say, okay, actually, let's make it 8th, because as you can see, the start time is inclusive, the end time is exclusive. So this will give us data from midnight of 1st June until midnight of 8th, which covers all the data up to 7th of June. So you can see what you have said, based on what you have selected, the calculations are shown here. So if you use the relative filter also, it will show you what's going on here. And now once you apply this will be the filter that is used for the time range. And as a very simple example, I'm just going to say this is a state level table. So I'm just going to say, give me, so you can actually search for the column name. So you have state code, state name. State code is actually present in case you want to plot a sort of geographical map. but it's present here as well if you prefer to look at it that way. So you can say state name, and what this means is you are going to group by this. So dimensions are nothing but how you're going to group the data, and metrics are important. What is the number that you're going to be looking at? So in this case, if you look at all the columns, you have all the helper columns like year, month, the ISO year and ISO week if you want to aggregate data by week. And then the day of week, hour of day, time block of day. So all these are helper columns that let you zero in on particular hours or particular time blocks across a period of time. And then you have the state name, the region to which the state belongs to, and then a few other columns. So the main number that we're going to look at is the average load. So let's just say we look at average load in megawatt. The unit is mentioned here. In most of the cases, you will find the variable name explains what it is, and the unit is also usually present. Now, what should be the aggregation function here, right? So this can be tricky. I'm just going to set it to average for now, just to show you a chart. And I'm going to call this average load. You can actually name your output column. So that's what I've done here. And then you hit save. So now you've set up everything, and I'm going to say create, and it goes back to the database, crafts a query and runs it. This is a beautiful but messy chart with all the 30 odd states and so on, right? So you can actually, if you just want to focus on a few, you can either limit the number of series, saying I just want 5, and it'll show you the top 5 by the metric, which is load. So let's just go ahead and do that. And this shows me the top 5, right? You could also use other kinds of filters. For example, let me remove this series filter, but let me filter by the region. Now the region, and I'm going to look at this. Now, in certain cases, the filter values will self-populate. In certain cases, if the table is really large, it may not self-populate, right? So, so what I'm going to do as a quick hack is, since I don't know what the regions are, I'm just going to go and say, let me change this state name. I don't want state name. Let me just put region in here just for a quick understanding of what regions are available, right? So when I do this, I get to see this set of regions. This is what is available over here, and so now I know what the regions look like. So I'm going to now change this back to state, and I am going to now say I'll put a filter where the region is set to, let's say, northern, and save it and update the chart. And this is going to go and update this chart in this manner. Now you might see some weird thing like this where it's going up in a straight line. So this particular way of plotting, plots a continuous chart, and as you hover over the data, it shows you the actual data points as a dot, right? You can also customize this by going here and saying show markers, which actually show the data points. And now you can actually make out that, hey, this jump over here that you see seems discontinuous, which means there was no data in this time period, right? So that's a good way to quickly check if there are problems. But once you check it, it does not make for a very beautiful chart, so you may want to get rid of it. Now, you see the filtered set of states for northern region, and this looks fine. Now you can actually save this chart. So let me just go ahead and save as demo state load and save this, right? Now that I've saved this, you can actually go back to charts and it'll show this chart here. And who can see this chart? So in Superset, the permissions work according to the datasets or the tables, right? So as long as anyone is allowed to view that table, they can also view any chart made by anyone on that table. So you can actually send this link to anyone at your organization and they will be able to see this chart. But let's say you want to allow some people to edit it. So you can actually go here and click edit, and you can add an owner to this chart and make them also someone with access to edit the chart, right? And that is definitely doable as well. So I'm going to just cancel this because I don't want to change it for now. So I'm going to go back to this. So if I click this, I come back to this chart and it's available. And I'll show you a few other things. Now, if you just want an image, you can go to download and just export the image, right? So we can just do that and just wait for a second while an image is exported. And if you look at it, you can see the same chart, it's been outputted as an image. You can use that to annotate or share it with someone. You can also download the CSV or the JSON. CSV is more common, so I can just say export the CSV, and you get the data as a CSV, right? So you can see, whatever data was plotted is available here. So I'm just going to close this. What else can you do here? So you can actually view the query and actually see what is going on in the query. So if you like SQL, you can actually start using SQL Lab itself, which is like a tool where you can write your own queries, where you can do joins between different data sets and so on, which is an advanced feature if you would like to use that. Now, what are some common other things you might do? So the time series or the line charts allow you to do a few advanced things. You can actually calculate rolling metrics, like a rolling mean or a cumulative sum and so on. And you can also define some settings as to define for the rolling period how many data points should be considered, and that's over here. And another useful thing is the time shift. So you can actually say compare this to 1 week ago, right? And update the chart. So this shows you an idea of what happened 1 week ago at the same time, right? And this is useful when you want to narrow down on whether something is going up or going down compared to last time, or are there any anomalies compared to that time. And you can actually add multiple possibilities here. Although with 5 lines already and one comparison, you're looking at 10 lines, it becomes complex. So let me just remove this 1 week and say I want to compare to 1 year ago. And for 1 year ago, you have a couple of options. You can either look at 1 year, which is like 365 days, or basically if the data is from 1st of June to like 7th of June of this year, it will just compare to 1st of June to 7th of June last year. But typically you do want to consider the weekdays as well, like a Monday should be compared to a Monday. So you can actually use the 52 weeks option, in which case the exact dates that it's comparing to might change for last year, but it'll make sure it's looking at 52 weeks ago and a Monday is compared to a Monday. So I'm going to just select that and update the chart. So this should give you an idea of what is happening compared to last year. And you can see that at least in UP, there is lower demand. Maybe it's less hot. There's something going on. And even in other states, it's generally lower than what it was last year, right? So this is a quick set of things you could do and understand the data, right? You can have a few customization options where you can add labels, you can adapt the formatting, put different bounds for the y-axis and so on. So there is some degree of customization that is possible here. Now I'm just going to go to a spreadsheet which shows you similar data. So this is how the data looks. So earlier I just said, let's take an average, and we are still let me just set this to original value. Okay. So here we are basically looking at time block level data. So if I look at this point, it is for 10:45 p.m. and the next time will be 11 p.m. and then 11:15 and so on. So if you just visualize the data in a spreadsheet, we can actually even try that here, where we remove this 52 week and we can actually try to see a pivot chart or a pivot table, right? So let's look at that. So here it's just showing you the pivot with columns as state, but there is no row. Maybe what we will do is, for the row, let's just add the time block column and just say update. Right, so this is really a visualization of the data where each row is a time block and each column is a state, and this is a good way to look at it as well. Now I'm just going to show you a spreadsheet over here, mainly to help you understand how to aggregate stuff, right? So if you look at this, each column here is a time block. So it's really the inverse of the sheet pivot table we made there, where the columns are the time blocks and the rows are the states, right? And each state belongs to a region. So there are 5 regions, and then the national level is basically all regions, right? Now, and on the time axis, you can aggregate 4 time blocks for the hour into the hour, and the second hour will have the next 4 time blocks and so on. Now you might want to perform various aggregates. So let's look at what might be happening. So for example, if you want just Uttar Pradesh for the hour, right? So what should be the metric that you use? Ideally, you will be using an average, and this is load we are talking about. So you will perform an average with this set to hour. So let's start looking at that. So let me go back to line chart. One second. And in the line chart, let's keep this as original value, and these filters are fine. I'm just going to update it. Oh, I think I made a mistake. So I'm going to actually stop this over here, so I can hit stop. So when you think your query is wrong, you can actually stop it. If you look at it, we've actually said time should be x-axis, but we've also put it in the dimensions. That's because we went to pivot table where it has a different structure, rows and columns, and we had added time block here. So I'm going to remove that because this definition here is enough, right? And I'm going to say update. And yeah, we have the chart that we started with. Now, what will happen if I move this to hour, right? So let's see what happens. So I'm going to say move it to hour and do the averaging. And it looks like basically a smoother version of what we saw before. And it looks fine. So now going back, let's look at the metric. It is still average, and this is fine. Now, what it basically did was take these 4 data points, which are highlighted for Uttar Pradesh, and create an average of those and assign it to this hour. So that's what just happened. And for each hour, for each state, it does this. And this is perfectly fine. But what if you want to do this across all states in northern region? Now, let me go back here. I'm going to change this back to original value, right? And I'm going to say update back to time block, right? Now, if I want to add all of these, which are basically the states in the northern region, so I'm just going to remove the state name from the dimensions. So there's no group by column. There's only a filter for northern, and I'm going to say update. So you see some data here, right? what has happened when we say average over here, we are at average over here. What it has done is averaged these, right? Is that correct? Is it correct to average these and say that's the value for northern? No, that is not correct, because northern is really, you take every data point over here and add them up, and that should give you the total for northern region. So really it should then become the sum of average load, right? And let's do that. Let's take a look. Once we do that, we get the correct set of values, and I'll just rename this for clarity. Region load is what we're looking at now, right? And I'm going to say update, and this shows you, it's around 60 to 70 gigawatts, and it looks fine. And what it has done is added up this set of values and assigned it to time block 1, added up this set of values, assigned it to time block 2, and so on. We are still okay, like this is still fine. But what if you want to aggregate at region for the entire hour, right? So ideally what should so that is one issue. It's not so straightforward. The second problem is for what we just did. Let's say you have in this case, 7 cells being aggregated here. What if a couple of them were missing, right? What if the data was just missing, right? Maybe we couldn't collect it, maybe it was not available, whatever it is. So then it could be misleading because you've summed up everything and it could show you a wrong number. So this means when you work with any data set, you need to be careful of this. And how do you validate this, right? How do you validate if the data is present and it's fine, right? So we are going to look at that for a little bit. So let's go back to this chart here. So how would we understand if something is missing? So the first thing we can do is go back to time block, and instead of just plotting the load, let's remove that. We are going to count, right? So counts are very useful. So you can actually count how many. You can either do a simple count, which will count how many times a state comes, but to be safe, you want to make sure they are distinct. You can actually use count distinct and save this and plot it. When you do this, you're basically counting how many distinct states exist for each time block. And here it appears that it's fine. It's always 9. And in fact, there is a gap here which shows there is some missing data from a time perspective. But whenever the data is present, it is present for all states. So the plot that we did is a safe plot because the data is not missing. But if there was data missing, we need to be more careful. For example, if you were aggregating by hour, there is going to be missing data. So the other kind of aggregation you may want to do is, what if I wanted to look at northern for the whole hour? So how will that look like? So ideally you will need to do 2 levels of aggregation. Why? Because you have to first add these up to get one value for northern for each time block, right? And let's just put a formula here just so that you can see the data. So this number is what you get for this time block, and let's just pull this across. And these are the 4 values that you will then have to add up to get the average for hour 1. So you're first doing a sum across this, and then once you get that sum, you have to do an average. And this kind of query is something that is difficult to do without code, right? So if you go here, there's no easy way to do just that. Now you could go to SQL and write a query, and those queries can manage this pretty easily. But we'll not get into that for now. So this is an example of something which is harder to do. But just coming back to missing data, another thing that you could do is check how many data points exist by date. For example, that's a very simple check that you can do. So I'm going to actually remove this region filter, and I'm going to just say, um, so the count metric is actually a saved metric. You can just go here and say count star. This is really useful. So I'm going to look at this by day, right? Because I don't want too much granularity there. So I'm just going to count this, and you can see that usually it's fine. It's around 3,260 records, but you can see a big dip on June 3rd, where we also noticed there was missing data, right? So this is another way for you to verify whether the data sets are there, and if they're not there, then you dig deeper. Is it time which is missing? For example, here we know it's missing, but we know that we checked that whenever state is present, all states are present. So it clearly looks like the reason the data is missing here is because there are some time blocks which are completely missing in the data. So when we aggregate by day for a day total, it gets harder because you do have missing data like this, and it can get misleading. Plus you have this problem where you can't aggregate all of these very easily, right? So we have a couple of ways to mitigate this. One is first, which you definitely need to check, is there missing data? And if there is missing data, you cannot do certain things. Like you cannot just say give me a total for this day, because there is definitely something missing. But let's assume there is complete data. So one thing that we can do is, it's easier to aggregate energy units. Load is something like a rate, like it's like velocity. Its power is equivalent to velocity when you think of driving a car. It is an instantaneous value, and aggregating it requires computations like this, where you're summing here and then you're averaging across time and so on. Whereas if you convert this to energy units, so megawatt, 5,400 megawatt for 15 minutes, you can actually compute the energy equivalent of that, and you can sum that up, and you can actually come back to megawatt units if you need to. Now, to make that easy, we typically give you the energy equivalent here. So if you look at the columns here, there is load, of course, and those units are mentioned as megawatts. And there is also MU with the label energy. What MU means is million units or million kilowatt hours. So you can actually use that to do your total. So I can do a region level total, and I can safely go to an hourly level here from the original value, from time block, and add the correct metric. So I'm going to say energy and total, and this time I have to do sum, right? Because you are summing up all the energy is like, for example, it's like distance traveled, right? So if you want to calculate total distance, you're always going to sum. So we are going to sum this, and then update this chart, and this is giving you some values, of course, showing that there is, due to missing data, there is a problem here. So the problem is clearer in energy, because energy, as you add up all the megawatts for all the time blocks, you will get a cumulative energy amount, and you can clearly see the missing data problem here, right? And so when you aggregate this for hourly, you can already see some hours have bad data, because maybe this 6 a.m. hour, we had only one of the time blocks which had data, and then the data went missing. And then for the 1 p.m. block, again, maybe only the 1:45 p.m. time block had data and the rest didn't. And in between, there is no data, right? And then the data becomes all right again. So energy is more useful when you are trying to aggregate across rows and across columns, right? So this is one way we solve the problem. And if you want to go back to a megawatt, you can actually do that by appropriately writing a custom formula. So you can actually go here and write a custom formula for how you would get back the megawatts. In this case, actually, it is straightforward because um, what happened is you have aggregated to hour. So this is total million kilowatt hours um, um, added up and aggregated to by hour. So it's really for each hour. So it's literally, if you divide by 1, which is 1 hour, you get back the um, value for gigawatts, right? And if you want megawatts, you have to just multiply by 1000. Right. So this is the way you can work with this data, and just so that you can perform these aggregations more easily, we have a more convenient table also, which is the hourly table. So in the case of hourly table, you don't have to. You can still. So we already aggregate each of these 4 values into a single value for the hour for Uttar Pradesh, and this way you can just do a sum across everything to get a value for northern region for that hour. So the which table you use depends on how much detail you want, um, and at what level you want to aggregate. So if you go look for energy again, so there's the real time, which is like at the time at which the data was sampled, time block, which is basically our aggregate for the time block, and then hourly, which is our aggregate for hourly. So this is how you would basically navigate between the different data sets and use it. I'll show you another example from daily data. So once you go to daily, um, it's usually not appropriate to look at load, because you are back to energy units for the day. So this state daily energy consumption table puts together actually multiple columns. There are lots of columns. This can get a bit overwhelming, from different reports, from 2-3 different reports by NLDC as well as RLDCs. So here we are going to look at again. So let's start with table. It's set to table. We never looked at it, so let's take a quick look at it. So I'm just going to say give me state name and save it. And in the metrics, I'm going to say give me energy. Now energy, there are lots of columns. They are usually self-explanatory. So you can see this is how much was scheduled for bilateral through bilateral agreements. This is how much they were supposed to draw from the national grid. This is from the various interstate generating stations with scheduled PPAs, and then there is electricity that they buy from the power exchange. And you can also see the overall schedule, overall supplied and shortage. So typically we look at the supplied, how much energy did they supply in their state for that day. So we're going to look at that. And we always have to supply an aggregation, even if we look at daily, which is the level at which the data is. So we should put some here, but in case we decide to go from daily to monthly and so on. So I'm going to say call this energy and put the units also just for reference, and say save. And I'm going to say show me last month. So this shows you what is the time period that it will pull the data for. And I'm going to keep it at day level, and I'm just going to create this and see what happens. Now you'll see that it's a simple table, and I said I want the last month, but what has it done? So it's just used the time as a filter. It has not used it as a group by column, right, or a dimension. So if you want that, you can just say include time over here. So when you say include time and update, it's going to actually give you the daily data. Now obviously this is just useful in terms of a file that you can export, but if you actually want to visualize it, you should go to one of the charts. So I'm going to show you how to search for a chart here. So I'm just going to search for line chart and select it and just update over here. And here you see the data. by different states and the total energy units. So here again, to aggregate, you have to be careful. What could be the problems? The problem could be that one of the days the data might be missing, right? So if you go from day to month, and let's say now I say last year, and gives me, or I'm going to just specify something custom where I say I want to look at from 1st of Jan onwards, and let's say I end it on 1st of July over here and say update. So it's given me the monthly data. The only issue here is now I don't know if all the time periods, all the dates for the month are covered or not. So again, you have to do those types of checks, like count how many dates are there in this month. So just to repeat that for you, I will remove this energy value and I'm going to say give me consumption date and count distinct dates, right? And I'm going to see, and it's going to say 31 days for January, 28 for February, back to 31 for March. So it looks okay, right? But May seems to have 29 days and there are 2 days missing. And then we are back to June, which again has 29 days. So there is a problem here. And so you do need to be careful in terms of how you do this. So one way to use the data at a monthly level from here could be that you use averaging, right? So let's see what you might do there. So you can actually go back to energy units supplied and say average. So you remember the data is daily, right? At a state level, and you're still aggregating to state level, and you're going to say give me the average, the daily average. Basically, instead of summing up all the days, give me the daily average, and you can update this. And this at least tells you what is the average per day, and you can extrapolate this to the monthly by estimating the missing. So it's a simple assumption where you say you take the average of the 29 days in May that were available and you scale it up to 31 days to represent the month of May. So you could do that, and you could either do it outside, or you can actually write a custom formula to do that, right? And if you want to know how to write these custom formulas, the SQL for that, you can Google for it and sort of do that. So it's probably out of scope for today's video, so I'll not get into that, but you can actually manage it within here if you would like to, right? By specifying a formula, right? And you can actually also create other kinds of metrics. You can say how much are they drawing from the grid, from basically the national grid compared to their generation. So you can put this energy units drawal average on the numerator and this one in the denominator, which is the total they supply, and actually update this chart. And this shows you, and this is a number between 0 to 1 because it's a proportion. Okay, so you can see that there are some states like, let's say, Chandigarh, which draws their entire power from outside, even Goa, whereas states like Andhra Pradesh or Uttar Pradesh are pretty self-sufficient, with only 25% coming from other regional stations, right? So these are some quick ways you can use different formulae here to generate the metrics you want, and this is exactly like what you would do in Excel with a pivot table. It's very similar to that. You can even put formulae within the metric, within the average, or you can put it outside, like in this case. It depends on what you're trying to do. So let's so I think this is good enough for a quick refresher on how to explore data.